We will next have a look at how pointers to base classes work in class-based polymorphism. A pointer that is set to the base, or parent class, can be used to access the derived, or child class. One of the key features of derived classes is that a pointer to the derived class is type compatible with a pointer to its base class. Polymorphism is the art of taking advantage of this simple, but powerful and versatile feature that brings object-oriented methodologies to its full potential. Program 65. Create a base class polygon with data fields, height, and width. A function named setValues is to assign the data field values. Derive two classes rectangle and triangle from polygon as base class, and a function named area to find area of rectangle or triangle. Use pointer to base class concept. Assign values, and print corresponding area. Here we go with the program code. I first declare the base class polygon. Since we will be inheriting this class, I would prefer declaring its data with scope of visibility as protected, and since this program is written to find the area of a rectangle or a triangle, I declare two variables, width and height. Just reminding you that area of a rectangle is width times height, and area of a triangle is half of width times height. We then set public visibility, and declare the function setValues, which assigns incoming values of a to width, and b to height. Next is declared the class rectangle. It inherits the class polygon. So these two classes are linked. The area function of this rectangle class returns the value of width times a height, which is the area of a rectangle. Next is declared the class triangle. It inherits the class polygon. So these two classes are linked together. Area function within this class returns the value of width times height, divided by 2, which is the area of a triangle. After these declarations, the program control shifts to line 25 in main function. An object, R, of the class rectangle is created. Since R inherits the class polygon, it comprises of all statements within polygon, and the statements within class rectangle. Then similarly, as on line 26 of program code, we create an object, T, of the class triangle. Since T inherits the class polygon, it comprises of all statements within polygon, and the statements within class triangle. On line 27, we instruct to create a pointer P1 that would point to the class polygon, and it would be assigned the address of object R. Hence in effect, the pointer P1 would point to the object R, and since as declared, P1 is the pointer that basically points to the class polygon within R, P1 would point to the block of statements related to class polygon. Likewise, on line 28, we instruct to create a pointer P2 pointing to the class polygon that is assigned the address of object T. Hence in effect, pointer P2 would point to the object T, and within it, P2 would point to the block of statements related to class polygon. Then on line 29 of the program code it is instructed that, from the location where pointer P1 is pointing to, execute the setValues function with parameter values 4 and 5. As per this function, width is assigned 4, and height is assigned 5, within this object, R. Similarly on line 30, the setValues function pointed by P2 is executed with parameters 5 and 10. So in this object T, width is assigned 5, and height is assigned 10. Then on line 31 of the program we first see out the message, area of rectangle. It's printed on output screen. Then we invoke the area function within object, R. It computes the product of width and height, which is 4 times 5, or 20, and returns it to the calling part, from where it's printed onto the output screen. On line 32, the process flow is same as above. Area of triangle is printed first. Then it's computed via the t.area function. The computed value of width times height divided by 2, that is 5 times 10 divided by 2, or 25, is returned and printed on screen. The program ends. So what did we learn in this program? We learned to set a pointer to the base class, and assign it with reference address of the derived class as per lines 27 and 28. Then we executed the base class function using the pointer to base class, as in lines 29 and 30. Finally we invoked the functions in derived class, using the object reference as is normally done. Let's next move over to virtual functions. Virtual members. A virtual member is a member of any class which can be redefined in its derived classes. In order to declare a member of a class as virtual, we must precede its declaration with the keyword virtual. A virtual member provides runtime polymorphism. Let's apply it in a similar requirement as we just completed in our last program. Program 66. Create a base class polygon with member data, height, and width. The member function setValues is to assign member data with data values. Derive two classes rectangle and triangle with polygon as its base class, and member function, area, to find area of rectangle or the triangle. Use pointer to base class concept, and declare area function as virtual member. Assign values, and print corresponding area. So here is the program code. I declare the base class, polygon. Scope of visibility is protected, and two variables, width and height, are declared. We then set public visibility, and declare the function, setValues, which assigns incoming parameter values of a to width, and b to height. Then comes the virtual function, area, which returns value 0. Next is declared the class rectangle. It inherits the class polygon. The area function of this rectangle class returns the value of width times a height, which is the area of a rectangle. Next is declared the class triangle. It inherits the class polygon. Area function within class triangle returns the value of width times height, divided by 2, which is the area of a triangle. After these declarations, the program control shifts to line 27 in main function. Here we have 3 declarations in one line. Object P of class polygon is created. It contains the entire block of code as declared and defined in the class polygon. Object R of class rectangle is created. Since it inherits class polygon, it contains the entire block of code as declared and defined in the class polygon, and also has code block from its own class, the rectangle. Object T of class triangle is created. Since it inherits class polygon, it contains the entire block of code as declared and defined in the class polygon, and also has code block from its own class, the triangle. On line 28 of the program code, we instruct to create a pointer pt1 for the class polygon, which is assigned the address of object R. Hence pointer pt1 points to the block of statements related to class polygon in object R. Likewise, on line 29, we ask to create a pointer pt2 of type class polygon. It is assigned the address of object T, so it points to the block of statements related to class polygon in object T. Then on line 30, we create the pointer pt3 for class polygon. It is assigned the address of object P, so pt3 points to the block of statements related to class polygon in object P. On line 31 of the program code, it is instructed that, from the location where pointer pt1 is pointing to, execute the setValues function with parameter values 4 and 5. The function executes. Width is assigned value 4, and height is assigned 5 within the object R. Similarly, on line 32, the setValues function pointed by pt2 is executed with parameters 5 and 10. So in this object T, width is assigned 5, and height is assigned 10. Then on line 33, the setValues function pointed by pt3 is executed with parameters 10 and 20. So in object P, width is assigned 10, and height is assigned 20. On line 34, we ask to print the area of rectangle. The area function pointed by pointer pt1 is invoked. Remember that this object also has the virtual function with same name, area, belonging to the class polygon. However, it is overwritten, and the area function rewritten in class rectangle is executed. The function returns product of width and height from object R, and the value is printed on screen. Next is printed the area of triangle. The area function pointed by pointer pt2 is invoked. Area function of class polygon is overwritten, and the function rewritten in class triangle executes. It returns the product of width and height divided by 2 from object T. The value is printed on screen. Finally, we ask to print the area of polygon. This time, the virtual area function, pointed by the pointer pt3 is invoked. It returns 0, and the value is printed on screen. The program ends. We just learned to declare a virtual function in the base class, and to override it with same function in the derived class. This feature helps programmers to implement runtime polymorphism, or, in other words, a function overloaded with multiple tasks can execute the exact requirement at runtime by late binding with the appropriate function defined in the appropriate object call.